Hello dear students, welcome back to Learn Physics. In today's video also we are going to discuss about the chapter Laws of Motion. So last class we discussed about the some of the numericals from the pulley and string problems, and today we are going to discuss about the constraint equations. So there are also constraint equations. So in constraint equations also we are for finding out the here also pulley and string problems only we are discussing, and different kinds of questions depending on the how we will be considering the equation if it is a constraint motion. So there we discussed only about one pulley and different masses will be there in one pulley, and here in this one we will be having more than one pulley also will be there. So such kind of equations how we will be solving. For finding out the acceleration, the same formula we will be using, that is net force acting on the system divided by the total mass, that is the acceleration which it is acting on the system. So for using the constraint method, how can we find out the relation for acceleration? First we will consider that. So here for that I have a fixed pulley. Pulley is fixed over here, and here one mass 1 is suspended over here. The other end of the string is attached with another mass. This is the second mass. Okay, and for that from the fixed end I am considering the distance of the displacement of first one and second one from the fixed end. The displacement from the fixed end to the first mass is x1, and displacement from the fixed end to the second mass I am considering it as x2. Okay, so we know that the total length of the pulley, length of the string will be x1 plus x2, that is equal to L. That will always remain constant, right? The pulley, the length won't be changing. So here I am considering it as x1 plus x2 as the total length of the pulley. So if I need to find out the velocity, v1 plus v2, that is I am differentiating. So differentiating a constant, we will be getting it as 0. So v1 equals v minus v2. Okay, and if I am differentiating once more, I'll get it as a1 plus a2 equals 0. That is a1 equals minus a2. Okay, but so here acceleration is acting while it is downward direction. Here in this acceleration acting in the upward direction. Okay, so here instead of considering acceleration in the opposite direction, we can consider as x1 increases, according to that x2 will be decreasing. If x2 is increasing, according to that x2 will be decreasing. Like that we can consider. Okay, so here using this constraint equation, how can you find the relation between the two objects? See here I am going to consider for the object first one here a fixed pulley. Here a fixed pulley, and from here the pulley is attached with a bigger mass. This is mass 1. Okay, and the other end of the pulley is attached with another pulley whose mass is, which is the one end is connected to the fixed mass 1, and the other end is connected with another pulley. Okay, so these ends are connected with other pulley, and the one end is connected to this mass 1 and the other end is connected to the another mass 2. So in this case, how can we find out the A1 and A2? The relation, how we can find out. Okay, clear? So first pulley and second pulley. The third pulley, one side is attached with 1 and the second one is attached with the 2. A1 and A2, how we will be finding out. So from what is the constraint method? From the fixed end, or from this end. This is the fixed end of the pulley, and from here I am considering the distances. This one as x1, and here this point I am considering it as x2. first mass and second mass. And from next, you see, from fixed end till here, I am considering it as x3, and from the fixed end till here, I am considering it as x4. So using, we are going to find out the relation for L1, L2 and L3. See here L1 and next L2 and L3 I am going to consider. First L1. What will be L1? This x1 distance and this one. Till here it is L1, right? So L1 equals x1 plus x3. That is equal to L1. Next, I am going to find out for L2. L2 will be this much length. So, what is this distance? This distance means here, I'll represent it like this. This distance is L2. What will be this value? I need to add these two distances. So, this much length is x1 and this length is x3. So, to get this distance, I can write it as x1 minus x3. Okay, I'll use this. Okay, x1 minus x3, that is only this side it became. Now for getting this one, I need the other side, the small distance. For that, x4 minus x3. x4 minus x3 equals L2. Next I am going to find out L3. L3, same way, how can we find out x1? L3 means it will be here, this is and this length. So x1 minus x4 will give you x1 minus x4 plus, then for getting this distance, x2 minus x4. x2 minus x4 will give you L3. Okay, so the acceleration also, how we will find out the acceleration? Differentiating twice. Right side will become equal to 0. Therefore, a1 plus a3 will be equal to 0. Next one is, see here, a1 minus a1 plus a4 minus 2a3 equals 0. And here x1, x2 minus 2x4. So we will be getting it as a1 plus a2 minus 2a4 equals 0. Did you understand, right? Here, how we are getting here, we are coming to this relation, x1 plus x2 equals constant L1. Okay, so if we are increasing x1, x3 will be decreasing. If we are decreasing x3, x1 will be increasing. Okay, so this total length will remain constant. For that, we are differentiating the x1 plus x3 equals L1. Differentiating once, it will become v1 plus v3. So we did in the previous case, right? Same way. Here, see, v1 plus v2 equal, we are differentiating once and once more we are differentiating. So here I am not showing the second differentiation. Instead of that, I am the double differentiating together. So a1 plus a3 equals 0, and here we are getting it as a1 plus a4 minus 2a3 equals 0. a1 plus a2 minus 2a4 equals 0. So here we can, while we are solving these three equations, a1 plus a3 equals 0, how we will solve? a1 plus a3 equal a3, instead of a3 I can write it as a1 equals minus a3. So second equation I can write it as a3 minus a3 plus a4 minus 2a3 equals 0. Therefore, a4 equals 3a3. Okay, and next one I can write it as, next equation I will get it as a1 minus a3 plus a2 minus 2a4. Instead of a4 I can write it as 3a3. So minus 2, 3a3, minus 6a3 I'll be getting. Okay, so while we are solving this, so next one, when we are solving, we will get it as equals 0. So here this will become what is that, a2 minus 6 plus 1 7 A3 equals 0. So we are getting it as A2 equals 7 A3. Okay, so instead of A3, sorry, so here A2 equals 7 A3. A2 equals 7 A3 we are getting, and A1 equals minus A3, right? Minus A3, A2 equals 7 A3. So the answer is A2. Acceleration A1 and A2, we got it as A2 equals 7A3, or we can write it as minus 7A1 also we can write. In any one way we can represent the accelerations. Okay, this is the method to solve the constraint method. Constraint method means how to solve the, if we have more than one pulley, how can we solve the equation. So here in this one, you would have seen that it is connected. These connected pulleys means these are not fixed. Okay, so these pulleys are not fixed. This is not a fixed one, and this also not a fixed one. Okay, so here we will be getting, since they are not fixed one, and only this pulley is fixed one. So, but the total length will remain constant. Okay, clear children? So next we are moving to the next question. So the same question itself, we are giving masses for the different object. Okay, so same question, it is fixed with one pulley is fixed over here. One side is attached with one mass 1, and here it is connected with another pulley. The other side is attached over here. The other side is attached with this one, and another one is attached with the here. It is 2. Second pulley. And here the tensions are, find their acceleration and tension they are asking. Now, here masses are given as these two blocks having mass 1 kilogram and 2 kilogram is given. We need to find out the acceleration and tension in the strip. Okay, so here it will be having already acceleration, we got it as A2 equals minus 7A1, we got it. Right, A2 equals 7A3, that one we can write it as minus 7A1. So acceleration, we already got it as minus 7A1. Now tension. How can we find out the tension? 2 kilogram is acting. Here acceleration 7A1 acting, 7A acting in the downward direction. So it will be having a tension in the upward direction. So here also massless tension in the upward direction. So 2T is acting upward direction. 2T, and this 2T will be acting here also, and 2T and 2T together it will give 4T, and here we will be getting a tension 4T. Okay, so now we can draw the free body diagram for each mass. I am considering for 1 kilogram. 1 kilogram mass. So for 1 kilogram mass, how can I consider? 1 kilogram, tension is 4T is acting upward direction, and for 1 kilogram mass another 2T is acting in the upward direction, and here from here again a T is acting in the upward direction. So altogether all the forces are acting upward, tension is acting upward direction. In 1 kilogram mass, how much force is acting downward direction? 10 Newton forces acting. 1 into mass into acceleration. 10 Newton is acting downward direction. So for 2 kilogram mass, I am considering 2 kilogram. Therefore 20 Newton is acting downward direction, and 1 T is acting in the upward direction. So now we are going to find out the total effect of all the forces acting on it. Okay. So here, what will be the total effect of all the forces acting on it? Here I am going to consider for the 1 kilogram mass. 4T acting upward direction. Along that we got it as 2T in the upward direction. 2T plus T. Okay, and minus 10 in the downward direction. That will be equal to mass into acceleration. What is mass? 1 kilogram into acceleration. We already got it as A. So I am writing it as it is acting in the upward direction. Okay. Next is, if Then for the 2 kilogram mass, tell me for 2 kilogram mass, T is acting in the upward direction, and so it is minus T I'll consider because acceleration is downward. Minus T plus 20, that is equal to, what is that? 2 into mass into acceleration is 7a. Okay, here I am considering it as A1 as A, therefore it is 7a. So while we are solving this, we will be getting it as T 20 minus T equals 14a. And from here I'll get it as 7T minus 10 equals a. So when we are solving this one here, we will be getting it as, we will try to avoid which one, a. Here 20t, 20 minus t equals 14a, and here 7 multiplying 49t minus 140 equals 14a. So while you are subtracting, while you are solving this, you will be getting t as 1.62 Newton and acceleration as 1.31 meter per second square. So clear, children? So initially when you are doing, since I explained this much, you will be feeling it as a big question, but it is not a big issue at all. So just try to find out the acceleration and the tension and acceleration one equation, relation you can find out using free body diagram, and you can easily find out the relation. So I hope this is useful. This video is useful for you. Please try to solve this one. Clear, right? In this kind of equations, first you need to draw the free body diagram. See here, tension T upward. Here also from here it is acting upward direction. Same tension will be acting on both the sides. Okay, clear? No need to consider the masses for this, since this is a what is that? This is a movable pulley. These are movable pulleys, so no need to consider the force acting on those two movable pulleys. Okay, dears. So that's all for today. So in next video we will be coming with some more examples. So I hope today's video is clear for you. And if you like the channel, please don't forget to subscribe, like, and share. Thank you, children.